In this video we're going to look at the calculated and measured values of a typical half-wave rectifier. So here at the moment on the oscilloscope I'm displaying my 12 volt RMS output from my 230 volt to 12 volt step down transformer, and I'm measuring a peak value of approximately 15 volts peak. Now, by calculation, a half-wave rectifier voltage DC is equal to 0.45 times the voltage AC. But this equation is not considering the voltage drop across the PN junction of the diode. So my measured values were about 11.82 volts is my value of AC voltage to my rectifier. My voltage DC I'm measuring across my resistive load is 4.8 volts. By calculation I should get about 5.3 volts, but if you then consider the voltage drop across the diode, it's pretty close to 5.3 volts. So I'm pretty happy with the circuit that demonstrates this relationship between the voltage AC and the voltage DC using a half-wave rectifier. So here is my circuit. This time I'm using about 150 ohms of resistance in series with my single PN junction diode. I'll just move the oscilloscope across. And there is my output waveform. That was just my multimeter turning off. So there's my connected circuit again. I've laid it out so you can follow it fairly easily, coming from the transformer on the red lead into the diode, out of the diode into my two resistors connected in series, and back through on the white lead, through to the black lead, through back to the transformer secondary. My oscilloscope I've got connected across the resistive load, one lead connected to the end of this resistor and the other lead of my oscilloscope connected to the end of this resistor, which happens to be connected to the anode of the diode. If you see carefully here, you'll see the little silver ring at one end of the band, which is identifying the cathode of the diode. The other end is the anode. So the positive polarity of this output will be where the red lead is connected. The cathodes always connect to the positive of the output for a rectifying circuit. Remember, the oscilloscope is showing peak values and the multimeter is displaying RMS values. So if you were to build this circuit, you should also be able to prove the equation of VDC is equal to 0.45 times the VAC, allowing for the voltage drop across the junction of the diode. So hopefully you found this little demonstration interesting. Thank you for watching.